At this very moment, you're on a space journey. Your destination? A supermassive black hole, one of the most mysterious and terrifying entities in the universe. Aboard your spacecraft, you orbit this colossal gravitational structure, whose force is so intense that it can even capture light. Then the question arises, what would happen if you fell into this black hole? What would you see? What would you feel? What would this experience be like? First, we need to understand what a black hole is. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. It forms when a gigantic star reaches the end of its life and collapses under its own weight. Matter is compressed into a tiny point, creating a singularity, a point in space where the laws of physics, as we know them, break down. Surrounding this singularity is the event horizon, the boundary of the black hole, which marks the point of no return. Anything that crosses this boundary, whether it's light, matter, or any other form of energy, is irrevocably trapped. But how do we visualize this? Think of a trampoline representing space. If you place a bowling ball in the center, the trampoline will bend. Now, if you roll small marbles around the bowling ball, they'll be drawn toward the center, eventually falling into the hole created by the bowling ball. The black hole acts similarly, bending space around it and pulling everything that comes near. Now back to your spacecraft. You decide to take a daring leap toward the black hole. But before you jump, there's something important to consider. The black hole you're approaching isn't just any black hole. It's supermassive, with a mass millions of times greater than that of the Sun. To give you an idea, if the Sun were a soccer ball, this black hole would be a sphere the size of an entire city. Its gravitational force is so powerful that entire stars, much larger than our planet, are sucked in and destroyed. These stars, along with other material, form a bright disk of plasma around the black hole, spinning at nearly the speed of light. This disk of matter, known as an accretion disk, is one of the first spectacles you would witness. As you fall toward the black hole, you'd observe this disk spinning rapidly. It emits a bright light, not unlike a fluorescent lamp, but far more brilliant and deadly. In fact, the friction between the particles in this disk heats the matter to absurd temperatures, billions of degrees Fahrenheit, emitting radiation that includes X-rays and gamma rays. To protect yourself, you'd need a special spacesuit, resistant to extreme heat and capable of filtering out this lethal radiation. For those not familiar with these terms, let's simplify. Think about how friction makes things heat up. If you rub your hands together quickly, they warm up, right? Now imagine this friction on a cosmic scale, where particles move at incredible speeds. This generates enough heat to melt even the most resistant materials. That's why the accretion disk around the black hole glows so intensely. As you fall, you notice something strange. One side of the disk appears brighter than the other. This happens because of the Doppler effect, which is also observed on Earth. For example, when an ambulance approaches you, the sound of the siren seems higher pitched. As it moves away, the sound becomes lower pitched. In space, something similar happens with light. The light waves on one side of the disk, moving toward you, are compressed, becoming more energetic and brighter. The side moving away has its light waves stretched, appearing darker. As you continue falling, something even more fascinating occurs. The gravity of the black hole begins to distort space and time around you. You notice that the event horizon itself, the invisible boundary of the black hole, seems to move away from you, even as you approach it. It's as if you're moving towards something that keeps escaping from you. This illusion is caused by a combination of relativistic effects predicted by Einstein in his theory of general relativity. As you accelerate toward the black hole, the light you see is distorted. If we think of a car quickly approaching you, the perspective seems to change. Things in front of you become more compressed, while things around you seem to move backward. In the case of the black hole, the light around is pulled by gravity, creating a similar effect. When you cross the event horizon, something unexpected happens, or rather, nothing happens. Unlike what many sci-fi movies suggest, crossing the event horizon isn't a dramatic experience. There's no bright portal or bottomless pit. You can still see the matter disk, distant stars, and even the spacecraft you jumped from. But now, something has fundamentally changed. You're trapped. From this point, there's no escaping the black hole. However, you continue to see the universe around you. The stars still shine, and time seems to flow normally. This is because, locally, space-time, the structure of the universe, still behaves similarly to what you experience outside the black hole. It's like being in a free-falling elevator. Inside the elevator, everything seems normal, but you're inevitably falling. As you get closer to the center of the black hole, the gravitational force becomes incredibly intense. Picture yourself holding a rope with an apple tied to the end. If you let go of the rope, the apple falls. Now, if the black hole were the apple, it would pull the rope so hard that the apple would stretch and break apart before it even hit the ground. This phenomenon is called spaghettification, a term that describes how extreme gravity stretches any object, including you, until it tears apart. At this point, your body would be elongated into a thin line of particles, as if you were being turned into cosmic spaghetti. This process occurs because the gravity at the center of the black hole is so strong that the difference in force between your head and feet is colossal, literally ripping you apart. And now we reach the heart of the black hole, the singularity. This is the point where everything we know about physics disintegrates. The laws of gravity, as we understand them, can't explain what happens at this point. The singularity is where density becomes infinite, and time and space merge into something that scientists still can't describe. It's like trying to imagine a place where 1 divided by 0 has an answer. It just doesn't make sense. Currently, physicists theorize that a new theory, perhaps one that unifies gravity with quantum physics, is needed to understand what really happens inside a singularity. Some hypotheses suggest that the interior of a black hole could even contain a new universe, or that it could act as a bridge to another part of our universe, something known as a wormhole. So, it's important to dispel some popular myths about black holes. We often see representations of black holes as orange circles with a disk around them. But this is a false image. The accretion disk actually shines in shades of blue and white due to the incredibly high energy involved. The orange color is used in images to represent intensity, not the actual color. Another common misconception is the idea that upon falling into a black hole, you'd see the entire history of the universe unfold before your eyes. This completely ignores the effects of Doppler and light aberration. In reality, the light from background stars would become distorted and blue-shifted, and we wouldn't see the history of the universe play out. So what have we really learned from this hypothetical journey? We've understood that falling into a black hole is an experience that challenges our understanding of physics and the universe. It's not just a fall. It's a journey through space-time where reality as we know it warps and twists in ways we're only beginning to understand. Science allows us to imagine and, in a way, simulate these extreme situations, but there's still much to discover. For now, we can only speculate about what really happens at the heart of a black hole. But each new discovery brings us a little closer to understanding the deepest mysteries of the universe. So, what do you think? Will we ever fully understand what happens inside a black hole? Or will black holes remain one of the greatest mysteries of the cosmos? Share your thoughts in the comments and suggest other fascinating topics you'd like to see explored. Thank you so much, and see you in the next video.